Hey everyone, can you hear me? I just want to check the audio out before I start talking too much. So if someone could just give me a little ping that they're hearing and seeing me okay, please do that. No one? All right, awesome. Excellent. Thank you, everyone. So happy New Year to everybody. I really appreciate you coming in to listen to me talk and show you a few examples of interacting with Polkadot, or actually technically Kusama. Although the interface is going to be, of course, very, very similar for Polkadot and Kusama. So any of the things that we do today, then we will, you should be able to also take with you to Polkadot. Just as a note, everything that we're going to do today, except for a very small little shortcut, is going to just to show you how you can do it, is going to be live on the Kusama network. So we will actually be interacting with Kusama. This isn't a dev chain or anything. You should be able to see everything that I'm doing, as well as using all of the scripts that I put together and all of the different programs. You should be able to follow along if you like. Or if you don't like, you can just watch me. So first, just so everyone knows, I put, let me just refresh, make sure we have the latest version here. This GitHub repository, I should probably share my screen so you can see what I'm pointing out. Give me one moment here. Otherwise, you're just watching me click things. Where's the share screen? Okay. If you go to github.com/Laboon, my last name, Laboon, /Polkadot apps, and I'll put a link to that in the chat. Oh, I'm sorry. I see J. Leon Y is having trouble seeing. You may want to, if you're having trouble seeing or hearing, you may want to try a different browser. That is a problem with mine. Sometimes Brave especially gives me some issues, and I have to swap over to Chrome. So if you'd like to follow along, again, please feel free to clone down that repo or simply just look at the files. I've got the layout of this presentation basically in the README, so you can follow along and see the different kinds of things that we're going to do today. So just to give you an overview of what we are going to do, we're going to talk briefly about what you can do with the Polkadot API. We'll set up basic connections both to an external and to a local node, and I'll talk about some of the special things you may run into, special issues you may run into running a local node and interacting with it. Reading constants from the chain, calling functions, and we've got a few scripts to do things, and so we'll build upon the basics of what we've learned. We'll subscribe to things and watch some accounts, and finally send some real transactions over the network, and again, programmatically using the API, so not using Polkadot.js or anything like that. And finally, I want to take a look at a more complicated script to show you what's possible to actually solve real problems and not really sort of the toy ones that I have in the scripts here. As well, at the end, I've got a few links if you're interested in digging a little deeper and making your own applications that interact with Polkadot. So something I want to clear up is that we're not going to be making, as part of this lecture, actual distributed applications. However, using what you learned here, this will allow us to then build dApps later on. But this is more for building tools that interact with Polkadot and give us in Kusama and give us information about it. The next lecture will be building upon that, and then building bigger and better tools based on the basics of what we learned here. So if you would like to follow along, make sure that you have the most recent versions of Node and Yarn. If you download this, if you clone down this repo, I have in my package.json all the dependencies that you need. There was a change made, as far as I can tell, last night or the other day, which broke the API a little bit. So if things don't work, you may want to try this yarn add at Polkadot API beta to get the latest version. And to run any of these programs, just run node and then whatever the name of the program is. So let's start with just showing a basic connection. I want to connect to Kusama. How can I do that? I want to back up 1 second here. One of the reasons that I provided so many of these little scripts instead of just putting them all in one big thing, I find that the way I learn best personally is taking a script, moving things around, trying different things until I understand it. So there are a lot of these different scripts here. I think I made like 10 or 11. And I really recommend that you play around with them, try doing different things, try connecting to different different systems, making different calls, etc. All right, so what do we need in order to connect to Polkadot? So first, we need to connect to a specific node. So as a distributed system, it's not as though there is one server out there that is Polkadot. So, but what we do need to connect to one of them. So using this, what we're going to do is set up an interaction with this line 1. An interaction via WebSocket with a Kusama RPC remote procedure call endpoint. So one of the interesting things about interacting with the Polkadot API is behind the scenes. You won't be aware of it, if you're doing something simple like reading a constant or something, but everything is just being done via RPC. And so you will be able to do a very low level if you'd like and interact with that. But most of the times we can just forget that that's really what's happening. We can just sort of call and ask for data and get that data back. So first, what we're going to do is we're going to say, hey, I'm going to use the Promise API and a WebSocket provider. So here, this WebSocket, endpoint. Kusama-rpc.polkadot.io. That is publicly accessible and should be available for anyone to use. I'll show you in a moment how you can connect to your own local server if you'd like to create your own server. So then we're going to create an API by using this API promise.create with the WebSocket provider that we've created in line 7. So we create this provider and we create the API promise interface here. So now whenever I would like to do something, I can just call API.whatever and it will give me that information. We'll talk more about sort of the organization of all of this data momentarily. But right now, I'm just doing something very simple. I'm getting the name of the chain to which we're connected. So const chain equals await API RPC system chain. And then I'm just going to print out what that chain is and then exit the process. So let's go to the command line and try that out. I'm just going to do okay. Can people still see me? All right. No, this is interesting. Yeah, I'm not sure what the problem is. Seems like a few people are having connectivity issues. I'm honestly not sure if that's on my end or not. I don't see anything wrong here, but you never know. Okay. So well, I'll just keep on going. Where was I? So let me embiggen this a little bit. People can see the screen. So we now have this basic connect. I'm going to just run it with node basic connect.js. Let's give it a minute to do its thing. Congratulations, we are now connected to Kusama CC3. As I mentioned, we also can connect to a local server, or really any server we want. There are a lot of endpoints out there. So if you look at basic connect local, you'll notice this looks, if you ignore the comments at the top for a moment, you'll notice this looks very similar, except I'm connecting to 127.0.0.1, port 9944. However, I do want to have you note, if you are running locally, you're going to need to make sure of a few things. When you run Polkadot, set your port, your WebSocket port. Make sure that it's set to allow external connections, and finally set RPC cores to all. If you're really interested in the details of why you need to pass in those params, you can look at this issue, but just know if you include them, everything should work fine. So let's run this in a different terminal tab here. Yeah, so allow. So I'm now connected. I'll sync up a little bit, but my WebSocket should be ready to listen for some calls from here. So now I'm going to call basic connect local JS. All right. So once again, I'm connected to Kusama CC3. However, this time I am interacting not with that publicly accessible port, publicly accessible endpoint, but rather with the local server that I'm running on here. You'll notice I'm still able to access it, even though I'm not, I was not entirely synced up. But since this is the chain name is a constant, I can just grab that, and it's not going to change from one block to another. So even though I wasn't entirely synced up there, I still got Kusama CC3. All right, so this is going to act as sort of the basic shell, if you will, for what we're going to do going forward. Something I think will be very apparent as we move on is, I started from this basic concept, and then as I wanted to do more things, I can just sort of add on to it. I'm going to go and I'm going to stop my local node because my fans are buzzing. Maybe you can hear that on the call. I'm not sure. So I'm just going to go back and double check every once in a while to make sure there are no questions. So if you see that happening, just know that's what I'm doing. All right. So now let's move on to actually doing something. So in the first script, or scripts, I guess, we were just connecting really to the network and just showing that we were connected to it. But usually you want to do something more than just connect to the network. So in read constants.js, I show you how to read a constant from the API. So constants are things that are a relatively constant feature of the chain. So there's something that no work needs to be done really to calculate them. If you call in, you can just get a constant. However, they are not constant like pi or e. They're not a constant of the universe. So these can be changed by the WASM being changed, the runtime being changed. So these are constant. We don't expect them to change, but while during the running of a script. But over the life of Kusama or Polkadot, they certainly could change because the runtime could change in the future. So here, this read constants, it's a very simple script where I just want to know what is the existential deposit for this chain. So the existential deposit is how much Kusama or dots need to be in an account in order for it to exist. If there are any less than that, it will get reaped. There's another addition you'll see here, this dot decimal places. So when we interact with anything via the API, we're going to be tabulating or counting the raw dots or Kusamas, right? And there are 12 decimal places. So you'll be interacting with them basically as integers and not as floating point or decimal places. So what you're going to see is I have this, and I do this quite often. There's this dot decimal places, which I'm just going to divide by, since most people want to see not the raw number of units, but rather the equivalent number of Kusama. So here we're going to do something very similar. Once again, we're in an async block. We get the WS provider, the WebSocket provider, and we're going to await a call for a response back from the API. So I've got API, const, balance, existential deposit, and then this interesting thing, toNumber. So toNumber is going to be available for anything that gives you a number back, and it will convert it into a decimal number. So when we log this, we're going to say the existential deposit for the chain is whatever this result we got back is, divided by dot decimal places, KSM. Finally, we'll exit just because once we're done with this, we don't need to do anything else. So let's try running this and see what happens. I'll read constants. So the existential deposit for this chain is 0.01 Kusamas. So if you're interested, one way of exploring the latest, this is sort of a hacky way to do it, but I do it sometimes, to see or you can just look at the API documentation, which I have a link to at the end here. But sometimes if I'm just like looking around, I'll do something like this. All right, what constants are available? And I'll do something like, I probably should have had a script that did just this, but live coding is always so fun, right? It means that I'm going to mess up something. I'm going to have some sort of typo. It's never a good idea to live code, but I like to live on the edge. So sometimes just to see what's available, I'll do this. And I can see what other kinds of things are available under constants. So you can see there's the data for nicknames. You'll see a lot of these, like for very large numbers, these arrays of bytes. Proposal bond minimum, treasury data, term duration. So this is just a very simple way of seeing what's available to do. It's a little bit ugly, but it's usable. You can see things: emergency voting period, cool off period, etc. All right, so those are constants. There are a lot of different constants out there, things with babe and grandpa and all this fun stuff that you might like to see. But you're probably interested in something a little bit more dynamic. So let's look at calling functions to see things that may change over the course of the script's lifetime or slightly longer. So if we look at read account, .js. Again, very similar, wrapping everything up in an async block. We're going to connect to a node. And I just found some random address that happened to have some Kusamas. It's one of the validators. If it's yours, I'm not trying to pick on you or anything. I picked a random one of all the validators that we're running. And here I'm going to call a function. So functions or queries are under API.query. So constants are under API const. Under query is all the different kinds of queries you can make. They're going to look very similar. You'll just notice that as you would expect from a function, they tend to take some argument, or they're going to have the parens indicate arguments or lack thereof, showing that it's a function really that we're calling, because we're querying the network. So here, I grabbed some address that I saw had some Kusama associated with it, and I'm going to await for API query balances free balance. So I'm asking, all right, what is the free balance here? Then I'll print out this address has a balance of, and once again, I'm going to convert it into Kusamas instead of the raw integer value, because that's how most people are going to think to look for it. So let's run this. All right, so that account has 444.44 ... Kusama free. So that's kind of interesting. We're now seeing things live as the data changes. We'll get different results for that, obviously. A quick way to make things a little bit more interactive and user-friendly is to add command line arguments. So instead of me just grabbing some constant address that this script will check, I'm going to show you a very quick and easy way to add reading and command line arguments with readAnyAccount.js. This is going to look very similar, except our address, ADDR, is going to be a variable instead of a constant, and we'll read it in from the command line args. So let's go to read any account. Again, looks very similar, and there is basically no error checking here or anything. If you're writing a more production tool, you'll probably want to have a little bit more error checking. This is just saying to read in the second argument from the command line. Why second? Well, the 0th argument is node, and the first argument is the name of the JS file that you're reading. So the first parameter really that you're passing in is 2. So really the arguments start at 2. So I'm just going to take in that argument, and then I'm just going to call free balance once again, but to the address that I pass in. So let's I'm just going to go over to Polkadot.js here. All right, so here's my account, or one of my accounts. I see 1.049 KSM, copying the address. And we'll try reading that from the command line. Here we go. Has 1.0494 KSM. And I just like to put raw there, especially with command line stuff, because then when we copy, and we'll have that available to copy and paste instead of having to translate between raw and the Kusamas all the time. All right, so go back to Emacs. So now we've went from just connecting to the network all the way to reading accounts and doing things. However, we also may want to know what's happening on the network, and one way to do that would be to just do basically a spin check, just a for loop, and keep saying, all right, well, what's in the account now? What's in the account now? What's in the account now? But what we can do with our API is actually subscribe to events. So we can have the API inform us when there's been an update, and then then we can do whatever we want with that data. So if we look at display data, this is a very straightforward subscription. So once again, we're going to connect to the WebSocket. We're going to retrieve the chain name just to have it. And here is the interesting part. So you'll notice that here we're calling into RPC, we're calling to subscribe. So we're going to get the headers from each block and then call this function whenever a new header comes in. So it's going to be very simple. We're going to say for this chain, block last header.number equals the hash last header.hash. So we're basically, what this script will do is just subscribe to new blocks coming in and then display their number and hash. So let's do that. All right, so we see block 503.947 has hash OX159 ... As blocks go by, we'll see them come in. So let's look at this one, OX63 or OXBA3 for 950. Let's look at Polkadot.js. Oops. Well, let's just, so 952 is 30 FFE. 952 0x3 FFE. So we can see that our very simple block displayer is giving the same information as Polkadot.js. And that shouldn't be much of a surprise because behind the scenes, Polkadot.js is using this API as well. It's all, in JavaScript, it connects to a WebSocket and uses the API to display and update that information. So if you've ever been curious how Polkadot.js does all of this, this really is how it's all happening behind the scenes. So we also can do something that's more specific. This might be something useful. I have an account watcher script. Look at account watcher. Again, very simple, a lot of the same boilerplate for creating something. But what it's going to do is, given some address, it's going to tell you anytime there is a change in the free balance of it. So what we have here is a wait for query balance is free balance. So this subscribes to the free balance. So your account balance is, and so what I'm going to do is start this up, and then I'll send some transactions, and we'll see it actually change. So I've got a couple of test accounts here. So how about this Bill swap? And I'm going to node account watcher for that address. All right, so current account balance is this. Now let's try sending that over to Bill swap 2. Okay, we see this finalized. And you'll notice that now that the account has changed, I sent 0.1. And in fact, I now have 2.000. You'll also notice it wasn't exactly 0.1. That's because the fees were also automatically deducted as part of the transfer. So this could be very useful if you want to keep an eye on your account and see what's happening. Just like when you use your credit card, you might get an update that it's been used. You may want to put together a script that alerts you whenever there's been some change to your account, or that someone sent you dots or Kusama, or to make sure that nobody is taking them out of your account. So let's actually leave that up and running for a while I show another interesting script. So far, all we have been doing is reading data from the chain. We haven't really been doing anything. If we want to do anything, if we want to send some extrinsics, then we're going to need to make this slightly more complicated. Our script's a little bit more complicated. What we're going to have to do in order to submit something, of course, we are going to need an account that has Kusama tokens in it. We're going to have to spend them. Now, we can do all of this manually, but the API allows you to very easily add an address along with its associated private key into a key ring. So I have on my GitHub the skeleton for this, but I didn't leave in the mnemonic phrase. Now, obviously, you would not want to put the mnemonic phrase directly in your application source code usually. But in order to make the code easier to read and ignore or get rid of any superfluous stuff, I'm just going to copy and paste in a phrase and run from there. But what we're going to do once we have a mnemonic phrase or some other way, indication of the private key, you can do this with the raw seed, although that's frowned upon. Generally, you just want to use the mnemonic phrase or some other storage. We're going to create a user from that phrase. And I'll just say, all right, sending from address, user address with the public key, whatever, to whatever user's address we pass in as an argument. And here, oh, actually, yeah, I'm always sending it to the same user. So it's just to make this simple. I'm going to create a transaction with API TX. So TX is any kind of extrinsic that we're passing in, which includes transactions, but can also include other things. I'm going to do a transfer to EOWSP, etc. And this is 0.0001 Kusama tokens. So remember, we never use floating point. This is just the integer representation of the raw number that we're sending. So we're going to transfer, sign, and send for the user. And then it'll tell us that it submitted it with the particular hash. And then we can look up that hash on Polkascan to make sure that it's gone through. So this looks relatively simple, but just so you know, a lot is happening behind the scenes that the API takes care of for you. So setting the nonce and doing all the crypto and putting the signature into the block. All of this can be done manually, but generally there's no real reason to do that. At least when we're working at this level. So let's try sending this. I'm going to, and if you're thinking of stealing this, I've got just a teeny tiny bit of test Kusama in there. Not really worth it. So let's run node tx.js. That's going to send this very small amount. I'm going to look this up on Polkascan. Oh, I see something happening over here. Yep. So you can see that this account just received a very small amount of Kusama. If I go over to Polkascan, I can look up the hash, that transaction hash, and I can see 0.00001 KSM was sent over to here. We can look at the balance transfers and see the history. And in fact, you can see some of the earlier history where I was messing around with this. Okay. So that's a very, very simple, very simple transaction. However, we may want to let people know when the transaction's actually been finalized and what the status is of it, and a little bit more information than just, hey, I'm sending it, here's the hash. So I have bettertx.js as well, although bettertx, now that I think about it, may not be the the best description. And I think maybe more detailed TX might be better, detailed TX. Again, everything looks very similar to what we did before. We create a key ring. We're going to make a user from that by starting with our phrase. So I'm just going to add the phrase in here. But we're going to do something a little bit more complicated here. So instead of just sending off the transaction and then forgetting about it, we are going to create a more complicated callback function here. So here, we're going to sign and send, but anytime there's a change in the status, it's going to update here, let us know what the status is. And once it's been finalized, we'll say which block it's been included in and give a little bit of data and information about that, and then unsubscribe because we don't care about that transaction after it's been finalized and included in a block. So just to make this easy to follow, let's add a very noticeable number there. And I'm going to node better tx.js. Not sure if it's taking a while. There we go. All right, so you can see we're sending from this address. We were ready. It was broadcast out to the network. I'm not sure why it got broadcast twice, and then it was finalized. So this transaction was included at block hash OXB14. We can see some information about if we look here about where the different parts of the balance went. If we look back at our account watcher, we can see that we gained a little bit of Kusama there. And if we look at Polkascan, which is our block explorer, if you haven't checked out polkascan.io, I highly recommend it. I'm going to look for this block hash, so we can see this block hash, which included 4 extrinsics, including our transfer of 0.000012345667 KSM. So now we've gone all the way from connecting to the network, viewing things, watching as data change, and actually sending transactions on the network. So one last thing that I want to briefly show you is Anton Lau, who is one of the technical educators here on our team, put together this Kusama Validator Stats, which is going to give you information, just to show you, I just want to very briefly show you what all is possible by writing scripts and doing using the API. So this is going to give information on all of the validators. So if you look through the code, which is in index.js, you can see getting API query staking stakers for the current validator, getting the commission rate for all of them, and then we're going to print out data about all of the validators, as well as include the highest and lowest staked. So again, this might be something that's useful for people to use. We can take these very simple scripts and really extend them out. It looks like there's a bug with the commission, so I apologize. Let's just look at highest and lowest staked. So if we run node index.js, it's hitting the API. It's going to look for all sorts of data here. So it's now looking at all the data for all of the current validators. So let's just give it a minute to complete here. All right, so altogether we have 8.2 million Kusama stake in total, 8.2 million produced, of which 3.2 million are bonded, which means our staking rate is about 38%. And the highest stake validator here has 112,000 Kusama, and the lowest 9191. We can also see a little, more detailed information, like who are all the nominators and how much are they staking. So you can see here, for instance, this lowest stake validator has 2 nominators, one of which is a whole heck of a lot of stake, and the other one just a teeny tiny amount. But we can see for each of these what their total stake is, how much they're self-staking. We did have commission. I don't know if the API changed. I'm not sure why it's giving me not a number right now. But then we can view all of this validator data. So hopefully this gave you an idea of how to start interacting with Polkadot. However, I do realize this is just a very brief introduction, and so there's a lot further that you can go with it. I really recommend, if you're interested, just fooling around with the scripts. I feel like that's a very easy way to learn and start making scripts and then later programs that do interesting things. However, I did include a few links at the end of the README of that repo, including a link to the full API, which includes a tutorial for getting more into depth and talking about things like more complicated transactions and multiple subscriptions and all kinds of interesting things like that. If you're interested in programming the UI, so creating your own React application or something similar that can interact with the Polkadot API, there's a good tutorial information here. If you'd like to create a sub app for Polkadot.js, the source is available online. So you can look at, it's entirely open source. So you can look at the Polkadot.js app and add your own items to it, or use it to help create your own UI and visualizations. There's also a link to a few different command line tools that can help with your development. So Polkadot command line tools here, which include a description of some of them at the bottom. Finally, I wanted to include a link if you're interested in doing this in TypeScript or just being a little more type aware and dealing with the more complicated structures. I have a link in there to the basics of types and dealing with types and enums and stuff with Polkadot.js. All right, so hopefully, like I said, this was a good introduction to what is possible with Polkadot.js. I'm going to apologize ahead of time in case anyone has any questions about my bad JavaScript. So I'm not my main programming language certainly is not JavaScript, so there probably is a lot of non-idiomatic code there. But pull requests are always accepted, or issues. I'm happy to answer any questions that you might have now. Oh, thank you. That's the problem. I see. Thank you. The commission changed from percentage to amount, and I didn't update the script. So, yeah. But if anyone has any questions, I'm going to stop sharing now. Feel free to ask using the Ask a Question, or if you don't have any questions now, that's fine. If you do think of them later, please feel free to email me. It's bill@web3.foundation. Or feel free, if you see me around in Riot or on Twitter, then yeah, feel free to do so. Oh, and that's a great. I haven't seen that the API Explorer.PolkAlert, but I would like to check that out. All right, I guess there are no questions. So thank you, everyone. Like I said, if you do think of something, please feel free to reach out to me. I'm happy to answer anyone's questions. All right, have a good day and have a great new year.